Welcome to aminacademy.com. In engineering mechanics, let us do some example problem regarding equation of motion in graphical methods. Look at this example. A gauge goes down a main shaft of 800 meter deep in 50 seconds. For the first quarter of the distance, only the speed is uniformly accelerated and the last quarter uniformly retarded. The acceleration and retardation is being equal. Find the uniform speed of the gauge while traversing the central portion of the shaft. Look at this figure. It indicates the situation of the problem here. Now this is OX x-axis and this is y-axis. Now O, A, B, C here, D and E. Here OD represent the time t1 for acceleration. This t2 represent constant velocity and t3 time for constant retardation. Now let OABC represent the velocity time graph. OABC represent velocity time graph. And OA represent a period of acceleration, and AB constant velocity, and BC is constant retardation. Now first of all consider motion of the gauge from A to O, O to A. So motion of O to motion of OA here. Initial velocity, for this initial velocity u1 equal 0 because it's go down from the rest, and distance traveled here, total distance is 800, that 1/4 of the 800, that is S1 is total distance 800 meter divided by 4, that is 1/4, that is 200 meter. A1 is constant acceleration. V1 uniform velocity. Now first we will find A1 is constant acceleration of the gauge and V1 is uniform velocity of gauge AD. V1 is uniform velocity, that is it indicates AD or BF. AD or BF. Therefore the area of the triangle OAD is equal, that is S1. Suppose it's equal S1, therefore S1 we can write as area of the triangle half, base is T1, height is V1, which is equal to 100 meter. From that we can get it T1 into V1 equal 400 meter. Now consider the motion of the gauge A to B. Motion of the gauge A to B. A to B. In this case, distance traveled S2. Distance traveled, that is S2 equal half of 800 equal 400 meter. Since quarter of the distance is for acceleration, quarter of the distance for retardation, so half of the distance, that is half of 800, is 400 meter. Now which is equal, that is 400 equal area of the rectangle, that is T2 into V1, T2 into V1, which is equal 400. From that, now this was one. That after that your time taken T1 equal the uniform speed of the gauge while transversing the central portion of the shaft. Here from the equation, suppose this is equation 2 and this is equation 1. So from 1 and 2, 1 and 2, we can say T1 equal, because both are equal to 400, therefore T1 equal T2, since because here V1 equal, both velocity same, that is V1 equal V1. And similarly, we can say T2 equal to T3, therefore we can say T1 equal T2 equal T3, because time taken for acceleration and retardation is same, so therefore you can say T1 equal T3, therefore you can say finally T1 equal T2 equal to T3. Since the time taken, total time taken equal T1 plus T2 plus T3, which is given 50 seconds. Already T1 equal T2 equal T3, therefore 3 T1 equal 50. From here T1 equal 50 over 3 seconds. Again consider the motion of the gauge from O to A. In this case, initial velocity u1 equals 0, distance traveled is 200 and time is 50 by 3 seconds. Therefore you can say is equal ut plus half at square. You can use the formula, and that 200 equal u1 t1 plus half a1 t1 square, which gives initial velocity 0, that is u1 t1 is 0, plus half a1 into t1 square is 50 by 3 square equal 200. From that we can use a1 equal 200 into 2 into 3 square over 50 square, which you can calculate your (200) into 2 into 3 square is 9 over 50 square equal 1.44 meter per second square. The speed of the gauge while traversing the central portion while traversing in central portion of the graph, central portion of the shaft, is that is v1 equal u plus a1 t1, which is equal, that is v1 equal u is 0 plus a1 is 1.44 into t1 is 20 seconds. t1 is 50 by 3. Therefore v1 equal 1.44 into 50 over 3 equal 24 meter per second. We have done. Please subscribe our YouTube channel.